7.2 Solving Linear Systems Using Substitution. Here we have some more practice. Let's look at the first example. Our system is x equals y minus 1 and 10x minus 2y equals 38. One of our variables is already alone, and that is in the first equation, x. Since x is already alone, I can take its value, y minus 1, and plug it in for x. So let's go ahead and do that. So 10 times x, which we say is y minus 1, minus 2y equals 38. And then we can go ahead and simplify the problem and solve for y. Distribute the 10, so we get 10y minus 10 minus 2y equals 38. Combine like terms, 10y and negative 2y is 8y minus 10 equals 38. Add 10 to both sides of the equation, and we get 8y equals 48. And last, divide both sides by 8, and y equals 6. Now, once we have y, remember that we're going to take it and plug it back into the equation we started with. In this case, the equation we started with is x equals y minus 1. But now we know that the value of y is 6. So we can replace y with 6. So we get 6 minus 1, which is 5. So our x coordinate is 5, and our y coordinate is 6, which means the solution to this system is 5, 6. All right, let's go ahead and look at the next problem. In the first equation, y is already solved for. So again, I'm going to take the value of y, which is 2x minus 5, and I'm going to plug it into the other equation where y is. So I'm going to write that out, 3x plus 4 times y, but y is 2x minus 5, and that needs to equal 57. Okay, so now we're going to continue. Let's distribute so we can solve for x. 3x plus 8x minus 20 equals 57. Combine like terms, so we get 11x minus 20 equals 57. Add 20 to both sides of your equation, and we get 11x equals 77. Divide both sides by 11, and you get x equals 7. Now again, we still have to find y, so take and plug x back in to the equation you started with. In this case, we started with the equation y equals 2x minus 5. But now I know x is 7, so I'm going to replace it. So y equals 2 times 7 minus 5. Y equals 14 minus 5, so y equals 9. So now that we have our y coordinate and our x coordinate, we can go ahead and write the solution to our system. The solution is 7, 9. All right, let's go ahead and move on to the next example. All right, here we have an equation, two equations, and if you notice in the top equation, x is already alone. So I'm going to take the value of x, and I'm going to plug it into the other equation. So where x is, I've got y plus 4, and then I have minus y equals 7. All right, if we go ahead and simplify this problem, y minus y is, wait, that goes away. So we're only left with 4 equals 7. Is this a true statement? So right now we have to ask ourselves, is this true or is this false? And hopefully you will identify that this is a false statement, which means there is no solution. Alright, let's go ahead and move on to the next example. Notice that in the top equation y is already solved for. The value of y is 2x plus 5. So I'm going to take that value of y and plug it into our other equation. So we have 2x minus, plug in y, 2x plus 5, and that equals negative 5. So now we're going to go ahead and distribute this negative. 2x minus 2x minus 5 equals negative 5. Well, 2x minus 2x go away, so we're left with negative 5 equals negative 5. Again, is this true or is it false? That's what you should be asking yourself. And again, hopefully with this problem, you will see that it's true. And if it is true, we can say that there are an infinite number of solutions. Alright, let's go ahead and keep practicing. Alright, x minus 5y equals 10 and 2x minus 10y equals 20. Notice in both of these problems that our variable is not by itself. I'm going to go ahead and start with the top equation, which is x minus 5y equals 10. And we're going to solve for x. So we're going to add 5y to both sides. And when we do that, we get that x equals 10 plus 5y. Now if I take my other equation, which is 2x minus 10y, I'm going to plug in the value of x into that equation. So right now I'm just going to copy the equation, 2x minus 10y equals 20. And here I'm saying x is 10 plus 5y, and that's what we're going to plug in for x. So we have 2 times 10 plus 5y, close your parentheses, minus 10y equals 20. Now we can go ahead and simplify this problem and solve for y. 2 times 10 is 20, plus 10y minus 10y equals 20. And 10y minus 10y go away, so we're left with 20 equals 20. So again, is this true or is it false? Hopefully you've identified that it is true, which means the solution to this system is all real numbers. Now remember, saying all real numbers is the same thing as saying an infinite number of solutions. Alright, let's go on to the next example. Y equals x minus 1 and x plus y equals 3. Y is already alone, so I'm going to take the value of y and plug it into our other equation. So we have x plus y, which is x minus 1, equals 3. Now if we simplify this, x plus x is 2x minus 1 equals 3. Add 1 to both sides. We get 2x equals 4. Divide both sides of the equation by 2, and x equals 2. Now we still have to find y, so we're going to take x, go back to the equation you started with, which in this case is y equals x minus 1, and now we know that x is 2, so we can plug that in. Y equals 2 minus 1, so y has to equal 1. So the answer to this system is 2, 1 as an ordered pair. Alright, let's keep practicing. Okay, y equals 4x and x plus y equals 5. Again, you want to make sure that one variable is by itself. In the top equation, we already have y solved for. Y equals 4x. So I'm going to take 4x and plug it into the other equation. X plus 4x, because that's y, equals 5. So then we get 5x equals 5. Divide both sides by 5. X equals 1. Now we're going to take that value, plug it back into the equation we started with. We started with y equals 4x. Now we know x is 1. So y equals 4 times 1, which is 4. So the solution to this linear system is 1, 4. All right, let's go on to the next problem. X equals negative 4y. So x is already solved for. I'm going to take the value of x and plug it into the other equation. So 3 times x, which is negative 4y, plus 2y equals 20. Now we can solve for y. Negative 12y plus 2y equals 20. Negative 12y plus 2y is negative 10y equals 20. Divide both sides by negative 10, and y equals negative 2. All right, now we got to find x. So go back to the equation we started with, which is x equals negative 4, negative 4y. I almost put x. All right, so x equals negative 4y. But we now know that y is negative 2. So we're going to plug that in. X equals negative 4 times negative 2. So we get x equals 8. So the solution to this linear system is 8, negative 2. All right, more practice. Next page. All right, x plus 5y equals 4, and 3x plus 15y equals negative 1. This is another example where neither equation have a variable that is already alone. So let's go ahead and start with the top equation and solve for x. So x plus 5y equals 4. Subtract 5y from both sides, and we get that x equals 4 minus 5y. I'm going to take the other equation, 3x plus 15y equals negative 1. Whoops, my negative isn't showing. And now that I know that the value of x is 4 minus 5y, I'm going to plug it in for x. So we have 3 times 4 minus 5y plus 15y equals negative 1. We're going to go ahead and simplify this. We get 12 minus 15y plus 15y equals negative 1. Our like terms here cancel, so we're left with 12 equals negative 1. Is this true or false? Hopefully you have said false, which means our answer to this problem is that there is no solution. All right, let's go ahead to the next problem. X plus 5y equals 4, and 3x, I just noticed that these two problems are the same, so let's skip it. Okay, next problem. 3x minus y equals 4, and 2x minus 3y equals negative 9. All right, so again, we've got to pick an equation and get one variable by itself. I am going to start with the top equation, and I am going to solve for y. So we've got 3x minus y equals 4. We're going to subtract 3x from both sides of the equation, and we get negative y equals 4 minus 3x, but we don't want a negative y, so we got to get rid of that negative by dividing everything by negative 1. So now we have y equals negative 4 plus 3x. I'm going to take my other equation, which is 2x minus 3y equals negative 9. And now that I know the value of y is negative 4 plus 3x, I'm going to plug it into our equation where y is. So just because we're running out of room here, I'm going to go ahead and continue that up here. We have 2x minus 3y, which is negative 4 plus 3x, equal to negative 9. So we're going to go ahead and simplify by distributing our negative 3. So 2x plus 12 minus 9x equals negative 9. Combine like terms, so we get negative 7x plus 12 equals negative 9. Subtract 12 from both sides. We get negative 7x equals negative 21. Divide both sides by negative 7, and we get that x equals 3. Now, we've got x equals 3, but we still need to find y. So, go back to the equation that we started with. In this case, we started with the top equation, 3x minus y equals 4. And remember that we solved for y and got y equals negative 4 plus 3x. Let's go ahead and take the value of x, which we now know is 3, and plug it in. Now, it wouldn't matter if you did that with this equation or if you did that with this equation. The only difference is that if you start with this equation, you're going to have less work. Okay, so let's go ahead and figure out what y is. Y equals negative 4 plus 3 times x, which is 3. Y equals negative 4 plus 9, so y equals 5. So now that we have x and y, we can write our ordered pair, and it is 3, 5. So the solution to this linear system is 3, 5. All right, let's take a look at some word problems. Joey is 4 years younger than Maggie. If the sum of their ages is 54, how old is each person? Well, let's start and break this problem down. We know that Joey is 4 years younger than Maggie. So here's Maggie, and whatever her age is minus 4, I know equals Joey. Here we only have one equation. Now, remember we're working on systems of equations, which means we probably have more than one. So let's continue looking at this problem and see where we can find our other equation. Here it tells me that the sum, that means if we add their ages, it should equal 54. So we're saying that Joey's age plus Maggie's age has to equal 54 years old. So let's go ahead and use some variables to make this a little bit easier. My first equation is j equals m minus 4. And my second equation is j plus m equals 54. So here is my linear system that I need to solve. Alright, notice that in the top equation, we already have one of the variables by itself, and that is j. So I'm going to take the value of j, Joey's age, and I'm going to go ahead and plug it into our other equation for Joey. So now I have my j plus m equals 54, and remember we're plugging in Joey. Joey is Maggie's age minus 4. Plus Maggie's age has to equal 54. If we simplify this, we get 2m minus 4 equals 54. Add 4 to both sides of our equation, and we get that 2m equals 58. And then we're going to divide both sides by 2, and we get that m equals, what's 58 divided by 2? Is that 19? Oh, that's 29. Alright, so m equals 29. Now, if I want to figure out what Joey's age is, remember that Joey is whatever Maggie is minus 4 years. Well, now I know Maggie is 29. So Joey is 29 minus 4 years. So I know that Joey is 25. Now, you're not going to write this as an ordered pair because it's a word problem. you want to write out your answer. So we could say Joey is 25 and Maggie is 29. Here is our solution. Alright, let's go ahead and try number 12, which is just like the one we just did. And let me clear that writing so we can read the problem. Okay, Monica is 5 years older than Jeff, so let's write that out. So Monica is 5 years older than Jeff. So if here's Jeff's age and I'm 5 years older, we're adding 5 years. My other equation is telling me that their sum, that means we're adding their ages, is 37 degrees. So Monica's age plus Jeff's age needs to equal 37 years. So there are our two equations. We can rewrite them with variables. M equals J plus 5 and M plus J equals 37. Now just like the last word problem, notice that our top equation M is already alone. So we're going to go ahead and take the value of M and plug it into our second equation. So we have J plus 5 plus J equals 37. Combine like terms, we get 2J plus 5 equals 37. Subtract 5 from both sides of your equation, and we get that 2J equals 32. Divide both sides by 2, and we get that J equals 16. So if I know that Jeff is 16, I can figure out how old Monica is. Remember that Monica is Jeff's age plus 5. And if Jeff is 16, that means Monica is 16 plus 5 years, which means Monica is 21. So again, we don't write this as an ordered pair. We need to write it out because it's a word problem. Jeff is 16 and Monica is 21. And that is the answer to this word problem. Alright, hopefully this extra practice is going to help you to better understand solving linear systems using substitution.